Okay, so just a quick heads up, this mic picks up like almost everything. So
if I say Shrek from over here, they can hear it?
Yeah.
Shrek! That mic is very
Thank you.
sensitive.
All right, so here's what we're going to be doing. I'm going to be reviewing some of the concepts with you first off. Then we're going to do like a little bit of a quiz just to see where you're at. At that point, if you guys have any further questions, comments, concerns, cries of despair, you are welcome to ask me then. But I understand that like these are concepts that we have covered recently. That means that you're probably more familiar with them, and so chances are you'll probably be pretty decent. So if you are, then you don't need to be here. If you're bad, then you can stay and we can work it out. Okay, so Pythagorean theorem, volume, and surface area. Okay, so just as a quick review with Pythagorean theorem, the concept runs something like this. A squared plus b squared equals c squared. That means that if you have side lengths, so these are the legs of the triangle, and this is your hypotenuse. If you have one of these lengths squared, the combined total squares will add up to your hypotenuse squared. Okay, so in this case we have a side length that is 3 units, 4 units, and then 5 units. 3 squared is 9, 4 squared is 16, and 5 squared is 25. Okay, it's pretty straightforward. If you haven't learned this yet in math, I don't know what to teach you. Okay, so this is where we're at. Okay, so let's just review. So just as a reminder, you have leg A, leg B, and leg C, or your hypotenuse. Sometimes you might be given the hypotenuse and you're asked to find a length, length B, for instance. So then what you would do is you would subtract your total length, your squared length C, from A, and that's how you would solve for B. Okay, so it works both ways, like A plus B, A squared plus B squared equals C squared, or conversely, C squared minus B squared equals A squared, or the other way around. Okay, so this is Pythagorean theorem. So let's take this and apply it to real life.
Yes.
Okay, here we go. Here's the math question that you need to solve. So if you don't have a piece of paper out, you need a piece of paper out. Can you please get one and a writing utensil? Yeah, go quickly. Oh wait, hold on, Agent. There's paper right there. It's already here. Just grab it. All right, so, ladies and gentlemen, I'm going to walk you through this question. Pretty simple. Mr. Finch is in a burning building. He is on the 3rd floor. There is a fireman. He is at the base of this ladder. He doesn't think he can make it up to Mr. Finch in time to save his life. Mr. Finch, because he's a scientist, knows that the human body can survive a drop of up to 25 meters. Free fall, head down. Just kidding, that's paralyzing and you're dead. So Mr. Finch is weighing the options. Does he stay in this burning building and die of smoke inhalation? Or does he jump to his uncertain demise? Nachin, this is a math question, not whatever it is that you're going to ask. So, it doesn't matter. This is how we're going to solve it. This is the question. Can Mr. Finch survive a fall from this height? You're trying to find X. Okay, give it a shot. Go.
Wait, that's not square, right? Do we round it to the nearest 10?
Round it to the nearest 10, yeah.
Wait, that's not square, right?
You're finding side length X. Yeah. So these are not square, no.
This is really sad for me to
Solve it. Yes, Nachin. What is your question?
If someone would fall from a height already their own height, it would
No,
die.
if you fell face
chance
down.
of like paralysis, a C-spine or something like that?
Oh yeah, no, you would definitely.
Third floor building, even if it was like 20 meters, then you would still probably die.
No, it's not.
Depends how close it is. Depends what's going
But the
So-
change in pressure, the time it is a second. Let's say it's 20 meters. That falls probably solve it. Yeah,
So this is a free fall. So he goes length down. So yes, he's just paralyzed, but he wants to know what's going on. He doesn't know when he walked.
This is so sad. 26 weeks.
Here we go. Ladies and gentlemen, we're going to go over the answer now. Okay, kiddos, this is it. Okay, so we are trying to find side length x. So it looks something like this. We know that this right here, your lengths are directly across or from your right angle is your hypotenuse, right? That's the longest length in a triangle or a right triangle. So we go 30 squared minus 15 squared is equal to side length x squared, right? So when we get that, we get 900 minus 15 is 225 is equal to 675. And then we square root it to get 25.98. Okay, or 26 if you round. Okay, so 26 meters. So your answer could be, if you're asked to have a word question, right? Because word questions are always worth 2, 1 for the word, 1 for the answer. Your answer would be, Mr. Finch, if he fell, would fall approximately 26 meters. So whether he lives or dies, who knows? Sketchy, right? Because it's around 25, but it's slightly more. Okay, it's too slow. He dies.
Like, it's smoking inside.
He just can't. His hands are bound, and he just needs to know if he can jump.
We know Mr. Finch never learned how to climb.
Yes. No one ever taught him.
No, Mr. Finch never learned how to climb.
Yeah, no one ever taught him. Okay, here we go. So 26 meters, or approximately there, should be your answer. 25.98 meters is your answer. Okay, so everyone okay with this example? Any questions? No? Yes, you have questions? No, you don't have questions? Excellent. Okay, moving on. Okay, so that's Pythagorean theorem. You're going to see maybe 2-3 questions on the exam for Pythagorean. All the ones that we're covering right now, you'll see a couple questions. Volume, surface area, you might see a little bit more, but if you can get the gist of it, then you'll be okay. In looking over the exam, it's not particularly hard, right? Like, to be honest. Okay, so if you can handle these examples, you'll be just fine. As we review surface area, you got a cheat sheet probably a couple weeks ago, maybe more recently. And it has all of your formulas on it. Okay, so rectangular prisms. When we're looking at surface area is like the entire coverage of your net of your object, right? So if you were to break down this rectangular prism into its net, all the little rectangles would be the surface areas that you'd have. Okay, so the surface area equations are as follows. We have the rectangular prism, cylinder, and isosceles triangle. I'll post this keynote in PDF form to Edmodo so you have it. But yeah, so this is just the gist of it, and then we're going to go through some examples of it together. Right now. Okay, so you don't need to feverishly copy it because I'll just post it to Edmodo. So here we go. Mr. Finch again. Okay, so Mr. Finch, I don't know if you know this about Mr. Finch, but he secretly loves to dress up in Jedi Master clothing and cosplay, and he actually films himself on his iPhone with a selfie stick, doing action shots of him being a Jedi.
That's weird.
Yeah, no, I'm just joking. He doesn't do that. Okay, so, but let's pretend he does, because it would be hilarious. So, Mr. Finch, for Christmas this year, decided to make an action DVD box set of himself, battling the forces of evil and things of that nature. So, Mr. Finch makes this box set. He has a 4-volume DVD set of him fighting evil. The dimensions of the DVD box are 8 centimeters by 4 centimeters by 12 centimeters. Okay, let's pretend that there's 22 people on staff at Richmond Christian, and he wants to give each one of them this gift of him in full action force. Okay, so he's going to wrap it in wrapping paper perfectly so nothing overlaps, and he's giving 22 of them. So the question is, how much wrapping paper will he need? Okay, so take some time, go through this example.
Centimeters square. All wrapped.
3,872.
Well, guess what? You got it wrong.
You know what, Teddy? You wanna go?
No, Rachel.
I could beat you in anything.
No, you can't.
Oh yeah, they should.
Yes.
You wanna go?
I got 7,000.
I got 3,872. Wait, you added all these together. Wait, isn't it?
What did he centimeters square?
Raise your hand if you need more time. Okay.
Oh, yeah.
Yeah, it's 7,744.
Go trick shot.
All right, here we go, kiddos. We're gonna break the question up, and then I'll answer it in chunks. So here's how we solve it. Okay, we're gonna go and figure out all the different side lengths. So surface area, again, is wrapping it entirely to cover all the surfaces to figure out how much area it takes up. Okay, so there are 6 surfaces on here. It's a rectangular prism that we need to account for. Okay, so it looks like this. 2 times 8 times 4 plus 2 times 4 times 12 plus 2 times 8 times 12. Okay, so here's what you get. 2 times 8 times 4 is equal to 64. 2 times 4 times 12 is equal to 96. And then 8 times 12 times 2 is 192. Okay, for a total of 352. Okay, now, this is the total surface area of one box. Okay, so now you take one box and there's 22 staff, multiply it by 22, and that gets you 7,744 centimeters. Okay, so the answer 7,744 centimeters squared.
Because 2 of each side.
704.
This is a rectangle. So there's a top and a bottom, 2 sides, and a front and back.
For what area? I mean,
Surface area.
I mean, you could have done more.
Okay, cool. Do you not understand why there's 6? Okay, that's the right answer. Yeah.
How do you find the surface area of a cone?
Okay.
Oh.
We don't need to. We do.
Okay. Moving on to volume. So we are just like motoring through this, and then I'm going to give you some examples, and then I'll figure out if you need any help with anything. So we're going to go into volume. Okay, the trick to volume is it's always your base area times height. Okay, so if you can figure out whatever your base area is and multiply it by your height, you're good. So if you figure out, like with a rectangular prism, your base area is just your length times your width. Okay, so L times W. In a triangular prism, like an isosceles triangle, you'll have your height times your base, okay, divided by 2, okay, because a triangle is half of a square or a rectangle. And then a cylinder, it's pi r squared times h, right, to get your volume. So pi r squared gets you your area of a circle. Okay, so let's just review. Now let us apply this to the very real question of, okay, Mr. Finch has decided to give up teaching and he has decided instead to make cat food. For some strange reason, he loves to store all of his cat food in giant rectangular containers. He then takes these rectangular containers from storage and he tries to figure out how many cans of this cat food he can make. Now, Mr. Finch, as you can see in this example, is dumping some of his handmade, homegrown cat food into his storage container. The storage container, as you might imagine, is in meters. Okay? But his cans that he produces are in centimeters. Okay, so your question then is, Mr. Finch wants to empty one of these giant storage boxes that is full of cat food, and he wants to figure out approximately how many cans he can produce using that full container. Okay, so this is a two-parter. Number one, you have to find the volume of the rectangular prism. You need to find out then how much that converts into cans.
But for the 6 cm, is that the
This is your diameter. Okay, this is another trick. Now, on your test, sometimes you'll get like a half line on the diagram, and sometimes you get a full line. This is a full line. So this is telling you this is your diameter, not your radius. Okay, so just pay attention to that on your diagrams. Yeah,
Did you draw these yourself?
of course I did. Yeah.
Oh, it's beautiful.
Thanks, I try.
Better than anything Mr. Finch could ever do.
I'm particularly proud of the Finch cat because it's hideous and horrific. Okay, also another trick. Ladies and gentlemen, 1 meter cubed is equal to 1 million centimeters cubed. Okay, so let me just explain this. So if you have one cube, let's say you have a cube, right? Okay, and this is 1 meter. 1 meter is equal to 100 centimeters, right? So this would be like 100 centimeters. And it would be 100 times 100 times 100 because that's like how you would understand volume, right? So 1 meter cubed is equal to 1 million centimeters cubed. So you have to remember that when you're doing the calculation. One meter cubed is equal to 1 million centimeters cubed.
1
Meter cubed is equal to 1 million centimeters cubed.
How many zeros are
6. Also, it's right here, so in case you are wondering what I'm talking about, it's right there in red.
Do we round to the nearest tenth?
You can round to the nearest tenth, but then the cans will be whole cans. So you might have some left over.
Okay.
Okay, so you just divided the.
I got 2, 5, 2, how many cans?
And then 6 meter cube equals 6 million.
Just kidding.
Then divided by 84.78 centimeters.
Alright, kiddos, I'm gonna give you like 15 more seconds.
So you can volume of this, you can divide it.
Oh!
Oh, wait, no, I didn't.
I know, only use the pi button. You've never used a pi
All right, here we go.
No, good.
Explanation is on its way. Here we go. So, really quickly, this is a two-parter. The first part of the question is finding the volume, obviously, of the rectangular prism, right? So, we know volume is calculated as base area times height. In this case, we have 2 meters, 1 meter, 3 meters. 2 times 1 is 2 times 3 is 6. So let's get you 6 meters cubed, right? Okay, we have already established that 1 meter cubed is equal to 1 million centimeters cubed, right? We know that 1 meter cubed is equal to 1 million. That's 6 zeros, Denny, in case you're wondering. Cubed. Therefore, it stands to reason that 6 meters is equal to 6 million centimeters cubed, right? This is math. Okay, so now we have established how many of these centimeters we have within this giant rectangular box. Okay, now we got to take that and then we need to figure out the volume of this can. So we know that pi times radius squared times h is equal to volume. So we can calculate the volume, which is 3.14 times radius squared, which is 9, times 3. Gets you 84.78. Okay, raise your hand if you got that far. Excellent. Okay, now all you have to do is you take 6 million centimeters cubed, you divide it by 84.78, which gets you 70,771.41 cans. Okay. And if you round it to the nearest whole can, then that gets you 70,771 cans, or thereabouts, and you have to drink the rest. Okay. Nasty. All right. So, are there any questions about this example? Okay. Meters cubed into centimeters cubed. No. Okay. Excellent. All right. Here we go. So that was just a quick rundown of the concepts. Now we're going to test it a little bit. I have here a really short review sheet. Okay, I'm going to give you 20-ish minutes to do it. It probably will take you 10 to 15, and then we'll go over the answers. And if you have any questions, ask me. If not, then we'll be done. Cool?